Okay, so in this next section, 9.4, it's actually one of my favorite lessons. I really like trigonometry, but section 9.4 is pretty awesome. It's called partial fraction decomposition. Now, partial means parts. Decomposition means breakdown. So really what this lesson is we're looking how to break down fractions into parts. Think about it like this. If I asked you what's 1/2 plus 3/4, well, you would get a common denominator, multiply this by 2/2. This would turn into 2/4 plus 3/4, which is 5/4. So what we did is we looked to combine fractions. We took these two fractions, combined them, and got 5/4. In this section, what we're going to be learning is taking one fraction and breaking it up into other fractions. That's the whole idea. So let me show you what this looks like. Let's take a problem like this. The directions are just going to be to decompose into partial fractions. All right, so for problem number 1, it says x plus 2 over x squared plus 12x plus 32. Okay. First thing you want to do is you want to make sure that you factor the denominator. So if we do that, we're going to get x plus 2 over, this is going to factor numbers that multiply to be 32, add up to be 12, would be 8 and 4. Now, the way this is going to work is we're actually going to break it up into two separate fractions. Each of those factors is going to have its own fraction, like that. We just have to figure out what goes on top. So I'll put an a and a b. So we have a lot of variables here. We have x's, we have a and b. The tricky part is we're actually solving for a and b. It's pretty easy to do. I mean, at this point, we're going to multiply by our LCD. The LCD is always going to be this right here, what you factored, which was x plus 8 times x plus 4. So we're going to multiply each fraction by that LCD. That's a lot of writing, but it's not hard math. Watch. Just multiplying every single fraction by that LCD to cancel out our fractions. These will cancel. This will cancel. This will cancel. So we wind up getting the left side is x plus 2. On the right side, we're just going to have a times x plus 4 plus b times x plus 8. Well, let's go ahead and just distribute that out, and I'll show you how this works. Okay, so at this point, if this equation is balanced, that means the total number of x's on the left side has to equal the total number of x's on the right side. So what I'm going to do is I'll actually group those x's together. Instead of saying ax plus bx, I'm going to write it a plus b x's. And then the total number of constants on this side has to equal the total number of constants on this side. Constants just means that they don't have an x. Remember when we were talking about polynomials, we said a constant has the highest variable power of 0, which just means there's no variable. Okay. We said that they have to be the same number, right? So the total number of x's on the right, a plus b, has to equal the total number of x's on the left. The constants on the left have to equal the constants on the right. Now this is a system. We learned how to solve a system before. This was really an algebra. So let's solve this using multiplication or elimination. I'll multiply the top by -4. So we could eliminate. The a's cancel. Remember, with elimination, we're always adding. We're looking to get the same number, but opposite sign. So we get that b is -1/2. If b is -1/2, we could just plug it back in and figure out what a is. So 1 or 2/2 plus 1/2 is 3/2. So what would the answer actually look like? Well, you would say that x plus 2 over x squared plus 12x plus 32 is equal to your partial fractions. Remember our denominators, I think we had x plus 8 and x plus 4. We said a was 3/2 and b was -1/2. Now we don't like having fractions over fractions like this. One thing that we're allowed to do is instead of having 3/2 like that, we could just write 3 over 2 times x plus 8. That's more proper to write it that way. And then plus -1 over 2 times x plus 4. Or even if you wanted, instead of having plus and negative, you could even just write it minus 1 over 2 times x plus 4. This would be your answer. Take a look at a few more problems. You'll get the hang of this. How about if I asked you to decompose 1 over 9x squared minus 1? Now that's a difference of perfect squares, right? So remember your formula. A squared minus b squared is equal to a plus b times a minus b. So 9x squared is really just 3x squared minus 1 is just 1 squared. So the denominator would factor to be 3x plus 1 times 3x minus 1. Yeah, let me just write this fresh here. We'll do the same thing we did in the last problem. Our least common denominator was 3x plus 1 times 3x minus 1. And it's just a little bit of writing, but that's not hard math. All the fractions are going to cancel out doing it this way. Okay, so this is the fun part. You cancel out all the fractions. Get 1 is equal to a times 3x minus 1 plus b times 3x plus 1. Let's distribute this out. And actually, we don't have any x's here, right? So because we have no x's, that should equal no x's on the right side. A times 3x is really just 3ax minus a plus 3bx plus b. Don't get confused with all the letters here, just go step by step. Let's group all of our x's together. We have 3a plus 3b x's, and then our constants would be negative a plus b. So if the total number of x's has to equal the total number of x's, that would mean that 3a plus 3b has to equal 0. And our constants, negative a plus b, has to equal 1. Using elimination, I'll just multiply this bottom row by 3. We get 6b is equal to 3. So b is 3 over 6, or 1/2. And if we just plug that back in, doesn't matter where we plug it in here. 3a plus 3 times 1/2 is equal to 0. Well, a would have to be negative 1/2, but let's see how this works out. We could divide by 3, multiply by 1/3. A would equal negative 1/2. So what would our answer be? 1 over 9x squared minus 1, we broke down into two fractions. Our denominators were 3x plus 1 and 3x minus 1. We know that a was negative 1/2, b was 1/2, but a more proper way to write this would be negative 1 over 2 times 3x plus 1 plus 1 over 2 times 3x minus 1. That would be the best way to write our answer. Okay. I have a couple more problems. Problem number 3. What if we had 3x minus 1 over x squared plus x? Well, first step is let's factor. And then each factor is going to have its own denominator. So we have x and x plus 1. We'll have a and we'll have b. Our LCD would be x times x plus 1, which we'll distribute. Cancel out our common factors. And we get 3x minus 1 is equal to a times x plus 1 plus b times x. So we'll group all of our x's together. Here's an x, here's an x. And our total number of x's has to equal 3, and our constants have to equal negative 1. Well, that's nice. So if we know a is negative 1, we could plug that in here, and we get that b is 4. So as far as our answer, 3x minus 1 over x squared plus x decomposes to be negative 1 over x plus 4 over x plus 1. So if you were to get a common denominator here and combine the fractions, you would get 3x minus 1 over x squared plus x. It's a cool thing. So we have one more problem to do. One thing I just want to mention here is look at our setup. You see how this is x to the first and this is x to the first? our top power is x to the 0. Look at this second problem. You see how it's x to the first, and our top power doesn't have any x's? It's 1 degree lower, x to the 0. And even with our first problem, the way we set up our first problem, the denominators were all x to the first power, and the top was 1 degree lower. In this last problem, what we're going to see is if the bottom is x squared, the top has to be 1 degree lower. So the top would definitely have an x in it. So let me show you how that works. What if we had a problem like 3x plus 2 over just x to the third plus 3x. So as always, we'll factor. And then we'll make our fractions. Now the tricky part comes in with the second one. You see how there's an x squared there? We definitely need an x on top. So let's put bx. But we always want to keep going all the way down to constants. So bx is linear, so we'll just put plus c there so that we went all the way down. We have 2, 1, 0. Now I haven't seen any problem like this on the final exam, but it is in your textbook, and I just want to make sure you can handle this. So if you have x to the second on the bottom, on top you're going to put the letter x and then plus the next letter in the alphabet. You'll never see like x to the third in the denominator. We're going to solve this the same exact way. So we're going to multiply all of our fractions by our least common denominator of x times x squared plus 3. We'll cancel out our common factors. So we wind up with 3x plus 2 is equal to a times x squared plus 3 plus x times bx plus c. Well, it looks like we're going to have an x squared term, but look, there's no x squared, so if it helps you, you could even just write 0x squared. Let's distribute out the right side. This is going to be ax squared plus 3a plus bx squared plus cx. We'll group all of our quadratic terms. We'll group all of our x terms. And then we'll group our constant terms. Well, the total number of quadratics has to be the same on both sides. So a plus b has to equal 0 because that's how many were on the left. Total number of linear terms has to equal total number of linear terms. Well, that's nice. It makes things pretty easy. And then our constant terms has to equal our total constant terms. So 3a would have to equal 2. Okay, well, we know definitely c is equal to 3. We know that 3a is equal to 2, so that means a is 2/3. And if we know a is 2/3, if a plus b is 0 and a is 2/3, b would have to be negative 2/3. Okay, so let's go ahead and write our final answer. So the final answer would be 3x plus 2 over x to the third plus 3x is equal to think this is how we broke it down. Let me just check the notes. X times x squared plus 3. Yep. And we said a was 2/3. So we'll have to straighten that out. We know that b is negative 2/3. And c was 3. Okay, so now let's write our proper fractions. One way to think about this is instead of just bringing the 3 down, let's just multiply the top and bottom by 3/3. That's really just multiplying by 1, but the top turns into 3 times 2/3 is just 2. 3 times x is 3x. We could do the same thing with the second fraction. If you want to get rid of the fraction on top, just multiply the top and bottom by 3/3. You'd wind up with negative 2x plus 9 over 3 times x squared plus 3. The denominators we could always leave factored, but that would be your partial fraction decomposition.